Hello everybody. In this video we are going to look at something known as canonical form representation of Boolean functions. So let us see what a canonical form is. So given any binary variable, suppose x I say is a binary variable or a Boolean variable, this variable can appear in two forms. Either it can appear as x or it can appear as its complement x dash. Okay, so if I now consider two binary variables x and y, I can have four combinations of x and y. I can have both x and y are unprimed, or I can have x is primed, y is unprimed, or I can have x is unprimed, y is primed, or I can have both x and y as primed or complement form. So with two variables I get 2 to the power 2, which is 4 combinations. Same way, if I have three variables, with three variables, say x, y and z, I will get 2 to the power 3, that is 8 possible combinations of x, x prime, y, y prime and z, z prime. Okay, so I can have 8 different combinations. And how do you get these combinations? Just take the decimal numbers from 0 to 2 to the power n minus 1. That means here, what is n? N is the number of variables. So if I have number of variables is 3, that is n is equal to 3, then I just need to write the binary equivalent from 0 to 2 to the power 3 minus 1. 2 to the power 3 minus 1 is 0 to 7. Okay, so total I have 8 possible values. So I will just write from the number 0, 1, 2, 3, 4, 5, 6 and 7. And then I will write their binary equivalent. Now since it is 3 variables, so I'm going to use 3 different 3-bit numbers. So 0, 0, 0 for 0, 0, 0, 1 for 1, 0, 1, 0, okay, 0, 1, 1, then for 4 I get 1, 0, 0, 5 would be 1, 0, 1, 6 would be 1, 1, 0 and 7 would be 1, 1, 1. So I get these possible values, and then I can write this as, this term I can write it as x dash. I'll just explain how I'm writing this, y dash and z dash. Okay, and this I'm writing as x dash, y dash and z. So can you notice a pattern here? What I'm doing is, if the bit, this is for x, this is for y and this is for z. Okay, we write it in this order. So if the value for x is 0 here, then I write it as x prime. And if it is 1, I will write it as x. Same goes for y as well as for z. So in the first, all 3 are zeros. Here all 3 are zeros. So all 3 are primed. In the second case, first 2 are zeros. So first 2 are primed. And the third, that is z, is 1. So it is unprimed. So x dash, y dash, z. Similarly, I can write for the third one, I will write this would be x dash, y, z dash. Number 4 would be x dash, y, z. Okay, this is x, y dash, z dash, x, y dash, z, x, y, z dash, and x, y, z. Okay, so how have I written these? I have reached these terms. I have reached these terms by making, if a particular variable has a value 0, then I use the term x dash or y dash or z dash, that is the primed. And if its value is 1, then I use its unprimed form. And then I combine all three using the AND operator. That's why you can see this is the AND operator. This uses the AND operator. So it is basically x dash and y dash and z dash. So this is how we have written it. Now each of these terms has a name, and this name is called, these are called mean terms. M-I-N-T-E-R-M, mean term. Each of these is a mean term. Okay, and we write it as, let me use again a different color here. We write this as M0. Second one we write as M1, M2, M3, M4, M5, M6 and M7. So these are the mean terms corresponding, okay, for each of this. Each of these is a mean term. And how do we, in general, we write it using the notation MJ, subscript J. So here I had used 0 because it is corresponding to the number 0. Here I have used 1 because it corresponds to this pattern, that is 001, which is for decimal number 1. So we can name the mean terms as M and M with subscript J, where J denotes the decimal equivalent of the binary number of the mean term designated. So this is your mean term. Now here we have combined each of these by using the AND operator. So it's like, because the AND operator is like the product of regular arithmetic, so this is also known as mean terms. These are known as mean terms, or they are also called standard product. Standard product. So this is the mean terms. Same way, now we can also construct another notation, where instead of performing an AND, like here we had performed an AND of all three variables, we can perform the OR, and we can get another term which is known as max term. So let us see that. So here you can see I have again the same three variables x, y, and z, and we have written the format 0, 0, 0, 0, 0, 1 in this format. Now if I consider that if the value here is a 0, okay, then I write x, okay, and if it is a 1, I write x prime. So this is just the opposite of what we did for our mean term. In the mean terms, we took, if it is a 0, we take it as primed. If it is 0, we take it as primed. If it is 1, we take it as unprimed. But for the second notation, if it is 0, then we take it as unprimed, and if it is 1, we take it as primed. And we combine them using the OR operator. So here what will we get? X is 0, so I will take is x. Y is 0, so y is unprimed. Z is 0, unprimed. And then I'm going to combine them not by using the AND operator, but by using the OR operator. So I get x plus y plus z. Similarly for the second one, x plus y plus z dash. And the third is x plus y dash plus z. Next is x plus y dash plus z dash. This is x dash plus y plus z. This is x dash plus y plus z dash. This is x dash y dash z. And last one is x dash plus y dash plus z dash. So now we have got the combination by combining the three variables using the OR operator. And each of this is called a max term. Max term, or this is also known as standard sum. This is known as the standard sum. Okay, because it's a sum, you can think of it like a sum of x, y, and z. And each of these are denoted by now capital M0, capital M1, capital M2, M3, M4, M5, M6, and M7. So our max terms are denoted by capital Mj, whereas our mean terms were denoted by small mj. So let us see how it works for a function. So we have seen max terms and mean terms. Okay, and here one thing you need to remember, that each of this is nothing but the complement of each other. A max term, let us take a max term, let us take, say, M0. Okay, what is M0? M0 is x dash, y dash, z dash. Now if I take the complement of x dash, y dash, z dash, what do I get? Complement. We follow the De Morgan's law. Okay, and what I get? X dash complement plus y dash complement plus z dash complement. And x complement, so complement of complement is this. So I get x plus y plus z. Isn't this equal to capital M0? Okay. So what I did, I took the mean term, I took its complement. And when I get the, what do I get? I get the max term. So the complement of the max term of the mean term is the max term, and vice versa. Okay, so this is something to be remembered. Okay, let us take a function and see now how it is going to work. So let's say I have a truth table like this. Again, x, y, and z. So here I have this table here, x, y, z, with all three variables, and I have two functions, f1 and f2. This is already given in the truth table. Now I would like to represent f1 and f2, the functions, as again sum of mean terms or product of max terms. Okay, two formats of expressing functions. Express as a sum of, first let us see, as a sum of mean terms. So representing a function as a sum of mean terms. So what we do, we take the mean terms which has a 1, in the truth table, in the function. Okay, so you take those mean terms, then what you do, you combine them using OR. Combine using OR operator. Okay, that is why it's called, first we take the mean terms and then we combine them using OR. OR is nothing but the sum. So sum of mean terms. So let's see for function f1. So in function f1, we are going to consider this has a 1, this has a 1, and this has a 1. So we are going to take those mean terms. So this the mean term would be, mean term for the second one would be, this is, if I write, this is M1, this is M0, M1, M2, M3, this is M4, M5, M6, and M7. So I can write function f1 as M1 plus M4 plus M7. So this is F1 as the sum of mean terms. I can expand this mean terms. Okay, what is M1? What is M1? You can see here. Small m1. Small m1 is x dash y dash z. You can see it from here also. X dash y dash z. So x dash y dash z plus what is M4? M4 is x y dash z dash, x y dash z dash and M7 is x y z, x y z. Okay, so this is F1. What about F2? F2, you see, we take the ones, this one, 2, 3 and 4. So this is your 0, 1, 2, M3, M5, M6, M7. So our function F2 would be M3, M5, M6, M7. And what is M3? M3, very easy. So just write the binary form for 3. 3 is 0, 1, 1. Okay, 5 is 4, 5. 6 is this and 7 is this. So x dash y z plus x y dash z plus xy z dash plus xy z. So now you can just these were only for reference, so you can remove this. So this is your sum of your sum of mean terms, representing function f1 and f2 as sum of mean terms. Now what about max terms? So let us look at max terms. So the same functions f1 and f2, if we take, okay, now instead of taking the ones, we will take the zeros. Okay, if we take the zeros, then what we get? We will get the complement of f1. We get the complement of f1. So we take this, 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 this and this. Okay, so we take we get f1 dash is equal to the values where it has a 0, that is m0, m2, m3, m5 and m6. So f1 complement would be m0 plus m2 plus m3, m5, m6, okay, m6, m7 was not there, m6. So 1, 2, 3, 4, 5 terms. So 5 terms. Okay, so this is only f complement. Now what do? We take the complement of this. Complement of this. So what you get? m0, m2, m3, m5, m6 complement. Okay. Now again here, what is complement? Complement is f1 itself. And how do we write this? m0 complement dot m2 complement, De Morgan's law again, remember, m3 complement dot m5 complement dot M6 complement. Now what is M0 complement? Remember, M0 or Mj complement is equal to capital Mj. The complement of a mean term is the max term and complement of the max term is the mean term. So what is M0 dash? Capital M0. What is M2 dash? Capital M2. Similarly, M3, M5 and capital M6. So what is capital M0? Capital M0 here. Capital M0 is x plus y plus z. So we continue in this manner. So capital M0 would be x plus y plus z. M2, you can check from the table, M2 would be x plus y dash plus z. M3 would be x plus y dash plus z dash. M5 would be x dash plus y plus z, and M6 would be x dash plus y dash plus z. This part is different. So here you have represented F1 now how as a product of max term. This is a product of the max terms. So product of max terms, and you have sum of mean terms. So any Boolean function can be represented either as a product of max terms or as a sum of mean terms. And when you represent a Boolean function either as a product of max terms or sum of mean terms, this is known as your canonical form. This is known as the canonical form. Okay. So that is all up in this particular video about canonical form representation.